And here we go, moving right along into unit vocabulary for redox. I hope that this redox quiz goes a little bit better for most people because some of these definitions are straight up in the actual word, like Leo, Gur, and oil rig. They'll be there, so just pay attention. Great picture for what oxidation is. Oxidation is losing, where reduction is gaining. We will figure out how to remember that, and in the first definition is how we remember that, because when an atom gains an electron, that is a reduction, and I know it, and we call it a reduction because the oxidation number goes down. It gets more negative. So if I was 0, it goes to -1. If I was 1, it goes to 0, but it goes down. It reduces. So that reduction word at least makes sense for one of the phenomena we see going on with charge and gain and loss of electrons. Oxidation, not so much, but we know reduction, so we get the other one by default. So this is when an atom loses an electron and the oxidation number increases. And they don't call it increasidation, they call it oxidation. Okay? Moving right along. Leo says Gur. This is one of your mnemonics that you may choose, and there is a list of what's going on. Loss of electrons is oxidation, gains of electrons is a reduction. So losing electrons is oxidation, Leo. Gur, gaining electrons, is reduction. Now, my buddy Monaco likes this one the most because it has the word electrons in it to remind students that electrons are what's being transferred. I always kind of figured that that was the first learning that we did, was that this whole unit is going to be about movement of electrons. So that's kind of, defeating the purpose. I'm an oil rig guy. I say oxidation is losing, reduction is gaining. What are we losing and gaining again? Electrons. If you need to have electrons in your words for your mnemonic, use Leo says Gur. Otherwise, use oil rig. I really don't care which one you guys pick, but if you notice, that's an obvious definition for what that one begins with, because when you see that cut and pasted definition, you know it's oil rig. You can almost do that one first if you want, okay? There's going to be some nice easy ones and some old words, so you only got to get a few new words done in this vocab quiz, you're out. Okay? Reducing agent. This is where things get complicated. Because this agent thing, LeBron James has an agent, but LeBron James's agent is not responsible for any of the points that he gets on the court, but he is responsible for some of the paychecks that he gets, right? So he has a role. So the reducing agent is actually the thing being oxidized. Okay, the reducing agent is oxidized. The oxidizing agent obviously is reduced. It's the opposite. So it's the species responsible for the reduction. So he's the one actually being oxidized. Remember, these things go hand in hand. They're equal and opposites. It's like yin and yang. We can't have one without the other. Okay, so this agent is referring to the other one, the one that's responsible for what's going on. So hence the oxidizing agent is going to be responsible for the oxidation, but he'll actually be being reduced. The species that's responsible for the oxidation, hence actually being reduced. Can't have one without the other. Oxidation number is pretty easy. These are oxidation numbers up top. We've been dealing with these ever since atoms, and this is the charge on the ion after it has gained or lost an electron. Remember, it's in the upper right-hand corner. We will be doing the crisscrossing and the uncrisscrossing to figure out oxidation numbers, okay? Half reaction, here is 2 of them. The oxidation half reactions up top, the reduction half reactions on the bottom. Most of the electrons are in there, and then when I put them all together, the electrons cancel out, and I have all the reactants on one side, all the products on the other side. We're going to go backwards. We're going to see this bottom one, and we're going to have to pull out and create the half reactions. So this is either the oxidation or the reduction reaction written by itself with the electrons. So the half reaction is just the oxidation or just the reduction. And we generally write both. We don't write just one. We generally do write both. Voltaic cell. This is a cool picture of a voltaic cell. We will use this later in our learning. This picture, we need to go back to a few times because this picture does a beautiful job of showing what's going on at the electrodes, okay, and helps us understand that. So we'll dig into that deeper when the time is right. A system that spontaneously converts chemical energy into electrical energy. So you need to link spontaneous to voltaic, however you can do that. Voltaics are spontaneous. Electrolytic is non-spontaneous. This is the one that needs the battery. So generally we remember that electrolytic needs electricity. not just produces electricity, it needs electricity. This is the non-spontaneously converts chemical energy into electrical energy. Electricity is required to make it go. Okay. The electrode. This is the metal piece that is going down into the solution. This is the conductor, generally metal, that conducts the electrolyte solution with the electrochemical cell. Then they have specific names. Anode is like anion, and cathode is like cation. Okay, so anode's positive. This is the electrode where the oxidation takes place. So you need to learn that, and this angry ox, red cat, is what's going to get us there. Okay, cathode is the electrode where reduction takes place, and how we remember that is the saying, red cat, angry ox. Okay, red cat, angry ox. There's a great picture. I'm probably only going to show it once. And this is what's going on. So we know that the anode is where the oxidation takes place. That's the angry ox. Okay, and then the red cat, the reduction happens at the cathode. We remember that by that acronym, red cat, angry ox. So there's a few acronyms in this unit, and I'm begging you, do not fight them, learn them, and use them. I literally cannot do the half reactions properly without writing oil rig on the top of my page and figuring out which one is losing and which one is gaining. It's not something that you memorize when you see the problems. It's just a process you go through. I've memorized the process. I trust it. I use it. I'm begging you to do the same. Salt bridge. This specifically allows the ions to flow. It's that piece there that says KNO3. This is very much needed in the voltaic cells. So it allows the ions to flow between oxidation and reduction half cells. Spontaneous reactions go all by themselves. It doesn't need energy to get it up over the hill. It just goes all by itself, and Table J will show us why. The reactivity of metals. Non-spontaneous requires energy to make it go, and this is in the electrolytic cells that need a battery. Okay. Old words, anion, going back to it. Addition of an electron, so an anion, annoying, negative. An atom that has gained an electron and becomes negative. Cation has a T in it, or it looks like a plus, so that's a positive ion, and if you like cats, then you got that going for you, and you can remember it that way. Okay, an atom that has lost an electron, therefore, is now a positive ion. With that, we are done with vocab. You are on to taking your quiz and moving on with your life. Let's not wait too long to do this quiz, please. Get it out of the way, nice and easy, and let's get into assign oxidation numbers.